Hi guys! In this video, you will learn how to deploy a machine learning prototype as a production-ready REST API. Let's get started. Imagine that today is your first day at Uber as a machine learning engineer, and your task is to improve the machine learning service that predicts estimated time of arrivals. The ETA is an estimate shown to users saying when is the driver gonna come to the pickup location. So as a starter, you talk to data engineers, other machine learning engineers in the team, come up with a set of relevant features that you could add to the model, you prepare the training data, you train your model, you evaluate it offline inside your computer, and then you save it locally to disk as a pickle. You're happy with the results, so you think it would be a good idea to deploy it to production. But the question is, how? So far, you have four things. You have a model artifact that you save locally to disk. You have an inference code, that is a Python function that pre-processes the input features, passes them to the model and output predictions. Third, you've also built a REST API wrapper around your code using either a Flask or Fast API. And then fourth, if you know a little bit of Docker, you can write a Docker file, which defines a Docker image. This is essentially a container that encapsulates all your code and eases deployments. And this is all fantastic. You can spin up this container locally, test, and everything works like a charm. But the problem is, as long as you don't deploy this container in the production environment, it has zero value. So the question is, how can you deploy this Docker container to the production environment behind a REST API endpoint? And the solution is MLOps. MLOps is a set of best practices and workflows that help you move models from development to production automatically in a safe way. So let's go step by step. Step 1. Push your code to a non-master branch and open a pull request. So the first thing is to use GitHub, GitLab to track all your code changes. I recommend you develop your code in a non-master branch that you can call as you wish. You commit all the changes and you push them to the remote code repository. Then you open a pull request. Why not merge directly to the master branch? The code in the master branch is the exact same code that is deployed in the production environment. So before making changes to the master branch, you really need to make sure that your code is working as expected. For that, we open a pull request. And this takes us to the next step. The continuous integration pipeline is a GitHub action that is triggered automatically every time you open a pull request trying to merge changes to master. And the end goal is very simple. We need to make sure that the new code version is better than the one running in production. A continuous integration pipeline for machine learning models does, among other things, unit tests to check, for example, that your feature engineering functions work as expected. It trains the model, sometimes using a smaller dataset to speed up execution. And then finally, validates the model. For that, you can use an open source library like Discard. And at the end, the pipeline can either fail because one of the steps did not complete successfully. In this case, you need to go back to your code or to another project if it has higher priority, or pass. So your code changes get merged to master, and the model artifact is pushed to the model registry. The model registry is a central repository for your machine learning models that helps you and your team track your model as it goes from development to production. The third step is if the continuous integration pipeline completed successfully, a new pipeline is triggered. This is the continuous deployment. And the idea is very simple. We need to take the code that is now in master branch and push it, deploy it to the production environment. So we need to put the Docker file that we define behind a REST API that is accessible to the rest of services inside Uber's infrastructure. So in this case, this GitHub action does essentially two things. First, pushes the Docker file, the Docker image, to Uber's central repository for Docker images. And second, triggers the deployment on the compute platform. Here there are several options. A very popular one is Kubernetes clusters. So in this case, you will need to define a couple of files called manifest and invoke the kubectl CLI. Another option is AWS Lambda, which helps you deploy models without managing infrastructure, so it's serverless inside AWS. And then the third are other serverless platforms, for example, Cereum Beam, or Model that help you deploy Python code without writing any Docker files. Bonus number 1. Machine learning systems are way more than just the model artifact that we tested in our continuous integration pipeline. So it's best practice to actually test it end-to-end. For that, you deploy your model inside a non-production environment, often called staging. So you deploy your model to staging and you test it so you can actually interact with the API and log relevant metrics, for example, responses and accuracy, and also latency if that's a key requirement. Finally, the most reliable but potentially dangerous way to test a machine learning model is to deploy it to production and to show it to a small amount of users. This is commonly known as testing in production, and there are several strategies. 3 of them are, for example, A/B tests, shadow deployments, or canary deployments. In any of the 3 cases, you need to add one more piece of infrastructure to your stack, which for sure Uber has, and it's called an API gateway. The role of the API gateway is to route every incoming request randomly to one of the models, either the base model that was already running in production or the test model that you want to assess. Traffic is often split in a non-balanced way, so you want to allocate most of the traffic to the base model that you know that works, and only a small fraction to the new test model. You monitor metrics, and if results look good, you progressively increase the amount of traffic that goes to the test model. Finally, if the test concludes well, you fully deploy to production and you merge everything to master. That's it for today, guys. If you want to get more free lectures on hands-on MLOps, subscribe to this YouTube channel.